So this is an introduction to outlier analysis. What is an outlier? An outlier is a data point that is significantly different from all other observations. It can be much higher or lower than the rest of the data. What is the role in energy analysis? Outlier analysis helps identify unusual energy consumption patterns, which may indicate issues such as equipment malfunctions, operational inefficiencies, or errors in data. So to calculate an outlier, we need to first calculate the first and third quartile. So to understand what is a quartile, let's see the definition. The first quartile is the value below which 25% of the data falls. Example, if you have a list of 10 test scores, 10 to 100, Q1 is the value at the 25th percentile. Here Q1 is 25. Since it separates the lowest 25% from the rest, so which is between 20 and 30. So here is the value 25, and the Q1 is the value which 25% of the data falls. So it's the lowest numbers within the 25th range. What is Q3? The Q3 is the value below which 75% of the data falls, which is like 75 here. So all this data here is within Q3. So it's the lower values. With the same list of 10 test scores, 10 to 100, Q3 is the value at the 75th percentile. Here Q3 is 75 since it separates the lowest 75% from the top 25%. So this is Q1 and Q3. So how it works? To calculate an outlier, first we need to calculate the first quartile, which is the 25th percentile, the third quartile, which is the 75th percentile, and then something called interquartile range. So what is this quantity? This is the quantity which is the difference between 75th percentile and 25th percentile. So we need that quantity in order to calculate the upper boundary. So this is the formula, memorize this. This is the formula of the upper boundary, Q3 plus 1.5 times IQR. IQR is the interquartile range. So once you calculate this upper boundary, anything which is above this boundary is an outlier because it's significantly higher than the rest of the data. So let's see the energy use intensity of 10 bank branches. So this is the energy use intensity in kilowatt per square foot. So the first branch is 50 kilowatt hour per square foot. So like this up to the branch 10, which is 49 kilowatt hour per square foot. So that's the data given. Arrange data and calculate Q1 and Q3. So first you need to calculate the Q1 48.25. Don't worry, this is a very easy calculation and we can show in Excel how to calculate Q1. It's just a formula you need to put to calculate Q1. And similarly Q3, you need to put a formula in Excel to calculate Q3. So once you put those formulas for these 10 bank branches, you will get Q1 as this one and Q3 as this one. Sorry. So this is the interquartile range is the difference between 50.75 and 48.25, which is 2.5. Once you get that, you can calculate the upper boundary. Upper boundary is Q3 plus 1.5 times IQR, which is Q3 is 50.75 plus 1.5 times IQR is 2.5, that is 54.5, which means anything here, any branch which is above 54.5 is a branch which is using high amount of energy and is an outlier. So we need to focus on that branch. Do you find any branch here which is higher than 54.5? I can see this branch 9 is 150 kilowatt hour per square foot, means it's high energy use intensity, means this is wasting a lot of energy in branch 9. We need to focus our attention here and implement energy saving measures to reduce the amount of energy. The next step is to identify the energy hub. Branch 9 with an energy use intensity of 150 exceeds 54.5, making it our energy consuming culprit. It seems branch 9 is throwing an energy party every day. We need to investigate why this branch is using so much more energy than the others. So next, I will demonstrate how to identify the outliers using Excel using simple formulas. Thank you. So this is the Excel worksheet which we will use to calculate the outliers. So to determine which branch is an outlier, here all the branches are given with their respective energy use intensity. I want to find the outlier, means the branch with an energy use intensity which is significantly higher compared to the rest, so that we can focus our attention and resolve that. So to determine which are the outliers, first step is to calculate the quartiles Q1 and Q3. So how to calculate the quartiles? Using simple Excel function. So it's going to be quartiles. Inc means including the first and last number. And then for the array, select all the numbers, comma. Which quartile you want to calculate? First quartile, just type here 1. So next, to calculate the third quartile, we'll use the same formula with a change of argument. Instead of 1 this time, it's going to be 3. So we could calculate the first and third quartile. Next, find the difference between them, which is going to be the interquartile range, equal to Q3 minus Q. So next, the upper bound formula is 1.5. Sorry, Q3 plus 1.5 times the interquartile range, 2.5, which is 54.5. Now to determine which is an outlier, first let me type the formula. If this value is greater than the upper bound, then it's an outlier, which means yes. Otherwise, no. So let's make the N capital. So see, the upper bound is always the reference point. So we want to make it absolute reference, means fix the value so that when we drag and fill the rest, it won't affect, this cell won't change. So just press the button F4 and see the $sign means it's fixed. Next, just fill in. So the next step is to see like which one is an outlier. So branch 9 is an outlier because 150 is significantly higher than the upper bound. So this is the only outlier. So we need to focus our attention in branch 9 to see what is going on wrong. Why is it consuming so much energy? So there are many ways to represent this data. One of the best ways is to just make a bar chart. So let me show you how to make the bar chart. Insert, recommended charts. And this is the clustered column. So I'll just label it as energy use intensity for different branches. So I want to put some title here if necessary. So just select the y-axis, add chart element, axis title, primary vertical. Energy use intensity, kilowatt hour per feet square. You can select that, go to add chart element. This is in chart design. Notice that this is in chart design. That's where you go to change the titles. Now go to the chart axis title and then primary horizontal. Branches. These are the different branches. And I don't need that. Next, to represent or to show the values of the energy use intensity, just click on the graph and then right click and then add data labels. See, it's showing the different values. For example, for branch 9, it's 150. If you want, I mean, it's not absolutely necessary, but it'd be nice to select the outlier and fill it with a different color to just highlight it that this is an outlier. So another chart which can be important is the box and whisker plot. So the way you are going to do it is that just select the cells, go to recommended charts. Notice it's in insert. All charts and see here box and whisker. So this is the box and whisker, and what it shows is the, so this is energy use intensity, and what it shows is the different values here. So for example, the dot means the outlier, which is 150. So this is also another way of representing it. So what is the main purpose of determining the outlier again? The outlier helps us to see like which branch is consuming more energy than an average branch, or like consuming much more energy than 75% of the branches are consuming, so that we can focus our attention there and implement energy efficiency measures. For example, we can change the rooftop unit with a higher efficiency rooftop unit, or we can change the chiller system, we can upgrade the boiler system so that it's more energy efficient. So that's why outlier analysis is so important. Thank you.